All right, let's talk about one of the biggest, most mind-blowing questions in all of cosmology. I know it sounds like something straight out of science fiction, but this is an idea that some serious astrophysicists are actually exploring.
Yep, you heard that right. The question we're tackling today is, could our whole universe, everything we know and see, actually be nestled deep inside a black hole? Think of it like a cosmic detective story, and we're going to follow the clues, starting with a really strange coincidence.
So you might be asking, where in the world does an idea this wild even start? Well, it all begins with a little bit of math that lines up almost suspiciously well. But before we get to that, let's make sure we're all on the same page about what a black hole even is.
Now, we usually picture a hole as something you can fall through, but a black hole is a real three-dimensional chunk of space. The gravity there is just so incredibly intense that it warps space-time itself, bending all possible paths back inward. Once you're in, there's just no way out.
That boundary, that literal point of no return, has a name, the event horizon. And for our purposes, you can think of the size of the event horizon as the size of the black hole. Now, this is where it starts to get really interesting, because, as it turns out, our universe has a horizon too. So you've got these two kinds of horizons, right? On one side, a black hole's horizon, which traps light with gravity, and on the other, you have our cosmic horizon, basically the edge of the observable universe. It's a boundary defined by time. Light from anything further away just hasn't had the time to travel all the way to us yet. They're two totally different things, but then you do the math.
There's this fun exercise you do in astrophysics grad school. You take all the known mass in our universe, and you calculate how big a black hole you'd need to contain all of it. And the answer you get, it is shockingly close to the actual measured size of our observable universe. The average density is a perfect match. Now sure, this could just be a wild coincidence, but it's a huge one. And believe it or not, it's not the only clue.
Okay, clue number 2. This one is much more recent, and it comes from just looking at how galaxies are moving out there in the cosmos. A brand new study is hinting at something that could totally upend our standard model of how the universe works.
So this team of researchers, they looked at the spin direction of hundreds of different spiral galaxies. The expectation was that it would be totally random, right? About half spinning clockwise, half spinning counterclockwise. But that is not what they found, not at all. They found a preferred direction. Just look at this data. You would 100% expect a 50-50 split, just random chance. Instead, the researchers discovered that almost 2/3 of the galaxies they looked at were all spinning in the same direction. It's not unanimous, but it is definitely not random. And that, my friends, is really weird.
So why is this such a big deal? I mean, come on, everything in space spins, doesn't it? Planets spin, stars spin, galaxies spin, but a net spin for the entire universe? Whoa, that is a completely different ballgame, and it sort of breaks all our rules for how things are supposed to form.
See, we know why individual galaxies spin. It's the same reason an ice skater spins faster when she pulls her arms in. You start with this gigantic, slowly churning cloud of gas. As gravity pulls it all together, the cloud collapses, and to conserve something called angular momentum, it has to spin up faster and faster. Boom, you've got a spinning galaxy.
But here's the crucial part. While each individual cloud collapses and spins up on its own, those initial little churns and motions should be completely random. You know, like turbulence. So the direction one galaxy spins shouldn't have any connection to a galaxy a billion light years away. Across the entire cosmos, all those different spins should just cancel each other out, averaging to 0.
And that's not just a hunch, that's the standard scientific view. The Big Bang was an explosion outward in all directions, pretty much evenly. There's no reason to think it would have given a collective coordinated spin to the whole universe. So if this new data is right, we've got a serious mystery on our hands.
And this is where it all comes together. This is where our two separate puzzles, that weird density match and this unexpected cosmic spin, might just have a single incredible solution. It all comes down to what a black hole remembers.
There's a concept called the no-hair theorem, which basically says a black hole is shockingly simple. Once something falls in, almost all of its complex details are just gone. The black hole only remembers a few fundamental things about what it swallowed, including its total mass and its total angular momentum, its spin. Okay, so let's connect the dots. What if our universe was born from a black hole? And what if the stuff that fell in to create that black hole spiraled in, kind of like water going down a drain? Well, that would give the black hole a net spin. And that spin is one of the very few things that would be preserved. Our entire universe could have simply inherited its rotation from its parent black hole. How elegant is that? It just fits.
Okay, let's take a breath. This is an amazing story, right? It neatly connects two totally different cosmic puzzles with one mind-bending idea. But, like with any huge scientific claim, we have to be good detectives and step back and look at the evidence with a really critical eye.
So let's just ask the big question. Does this incredible theory actually hold up? Have we cracked the case? So here's where we stand. That density calculation, it's a super intriguing match, but, it could still just be a coincidence. The universe having a net spin, now that's the really compelling piece, but the evidence is still very, very preliminary. So what's the verdict? It's a fantastic idea that is starving for more data.
And this is the main reason we have to be cautious. The study that found this net spin, it looked at just a couple hundred galaxies. That is a tiny, tiny fraction of the billions and billions of galaxies out there. It's kind of like trying to predict a presidential election by polling one single small town. The result is interesting for sure, but we just can't be certain it represents the whole country.
So for now, the scientific community is hitting the pause button. That finding absolutely needs to be checked and confirmed by other, much larger studies. You've heard the saying, extraordinary claims require extraordinary evidence, and this idea is about as extraordinary as they come.
But honestly, whether our universe is inside a black hole or not, just asking the question is so powerful. It's a perfect reminder of all the fundamental, jaw-dropping mysteries that are still out there, just waiting for us to solve them. It's what pushes us to keep asking the biggest questions we can imagine. Until next time, keep looking up.